The problem we are going to focus on is the optimization problem from the Week 10 written quiz. In this question, given the known information, we're supposed to determine where along the 5-meter side the pole should be set up to minimize the amount of tarp.
Before we even start, I want to talk about the first problem-solving strategy, which is to read the problem carefully. Don't rush. Make sure you really understand the given information and what the question is asking for. For this question, we need to work out where to set up the poles and the least amount of tarp used.
After reading the question carefully, it's time to draw a diagram and label related variables. In this question, the diagram is already given. However, we still need to label our variables. Remember, always label your variables clearly and explicitly. This is especially important in optimization problems.
After applying the first two strategies, it's time to actually do the work to solve the problem.
While you're solving the problem, labeling or explaining steps is always a good habit. It not only helps you to stay organized, but also makes it easier for the grader to follow along.
After applying these three strategies mentioned earlier and the steps needed to solve optimization problem, we have found that the first derivative, which is this super complex thing being boxed up. Many people are stuck on finding the critical points because they don't know how to simplify this complex function to find its zeros.
This brings us to the last strategy we are going to talk about today, which is graph things out.
When you have a complex equation or function that needs to be solved, instead of solving it algebraically, which should be really hard sometimes, you can always use a graphing app such as Desmos or GeoGebra to graph it. This graphic approach often allows you to find your answer in a quick and clean way. In this problem, I graphed the first derivative, and as you can see, the critical point is found right away. The first derivative function crosses the x-axis at x equals 2.5, and that's our critical point.
Yay, we found our critical point. Now all we need to do is to complete the problem. After we figure out the hardest part of this problem, which is finding the critical point, I'm sure the rest of the problem would have been too hard for you.
Keep these four strategies in mind. We are sure you are now able to solve many problems you were stuck on before.